in like a year, and then I'll have my degree. So today we're going to do something called a number talk. A number talk is just a quick, probably like 10 or 15-minute lesson where we look at a math problem, we think about different strategies about how to solve it, and this helps us build something called our number sense. Number sense is the ability to take numbers and move them around and change how they are calculated together in order to come up with a solution to a problem. Because you can solve math problems so many ways. Okay? So when we practice our number talks, it helps our brains start thinking about numbers in a different way where we can use them, and it helps make other math problems a little bit easier because now we're building our toolbox of strategies that we can use to solve math problems. Okay? So the goal of today's lesson isn't necessarily to get the correct answer. Everybody always hopes to get the correct answer, but my focus today is the strategy that you use to come up with your answer. So I want everyone to feel that this is a safe place to share your ideas and your thoughts and be able to participate because this is a discussion that we're going to have. And so that means we're going to have some social norms. We're going to have some agreed upon rules of how we're going to behave during our number talk so that everyone feels safe to share their ideas. Those, I don't want to say rules, but those guidelines, those norms for this number talk are that we're going to be respectful of each other. We're not going to talk over each other. Instead, we're going to raise our hand and take turns. When someone has an idea that you might think is a little bonkers, let's say my math problem is 2 plus 2. And someone says the answer is 75. And we all know that it's not 75, right? It is. Sure. But we are not going to be like, oh my God, they said 75. What do they think? Because that doesn't make them feel safe to share their idea, right? Would that make you feel safe to share your ideas if people laughed at you? No. So instead, we're going to practice our best poker face. Poker face means no emotion, no reaction, just neutral. That way everybody feels safe to share their ideas. So let's say I say 3 times 3 is banana. Show me what face you're going to do. You all would be excellent poker players. All right. So this is how our number sense is going to work. I'm going to write a math multiplication problem on the board. After I do that, everybody's going to remain quiet and be thinking in their head how they are going to solve this problem and come up with a solution. Now, I know we get really excited when we want to share our ideas with the class. And so I've seen a lot of kids and they're like, I know. Because if you're a person sitting there still trying to think and someone's over here like, I know, that makes me feel like, oh my gosh, somebody else knows and I don't know yet. Just to be a calm, let other people think environment, okay? So instead, if you come up with a solution to the math problem, I want you to do this, a thumbs up on your chest. We're going to put it on our chest because then that way, nobody can really tell if you answered or not, or if you have a solution yet or not, but I can tell, okay? And then after you come up with your answer and you have a solution and a strategy of how you figured it out, I want you to keep thinking of another strategy because like Mrs. Harri said earlier, there are so many ways to solve a problem. So if you come up with another strategy, I want you to put your pointer finger up like this. Everybody show me what you're going to do with you when you have 2 strategies of how to solve our math problem. Excellent. What's it going to look like if, say, you came up with 4 strategies of how to solve our math problem? What would you do? Yeah, we're going to put 4 fingers up. Excellent. Now, when someone shares their idea, so I put the math problem up here. Y'all are thinking, you're putting up your fingers for how many strategies you've come up with how to solve that math problem. After I've given you all some time, then I'm going to say, all right, who would like to share their answer? And you're not going to tell me how you came up with. You're not going to tell me your strategy yet. You're just going to tell me the answer. If you hear someone else say the same answer that you came up with, I want you to do this. I think we've used this before at Jack Harvey, but this means agree or the same. I came up with that too. Show me how you do this. Excellent. Another silent way to communicate. Also, sorry, I forgot a step. While you're thinking, if you're bonkers stuck, that's okay. Just go like this. If you do a sideways thumb, then I'll know that you're thinking, but you're feeling a little stuck. Okay, show me how a sideways thumb looks. Excellent. All right, so what are you going to do if you agree with somebody's answer? Fantastic. All right, so then after I list everybody's answers on the board, I'm going to have you turn and talk to a neighbor quietly about what strategy you used, what answer you came up with. You're going to have like 30 seconds to do that, and then we're going to come back together and I'm going to say, who's going to be a brave volunteer and share with me their strategy? And you're going to go nice and slow and explain to me how you solved this math problem, and I'm going to write how you did it on the board because that helps everybody else visualize or see the math that you did in your head. And by the end of the lesson, hopefully we're going to have several different ideas of how to solve the math problem. And that'll make you all the more ready for the next time you come across a math problem. You'll be like, oh, Ellie came up with this idea. That was a really good strategy. I might try that this time. Okay? We understand? Are we ready? All right, I'm going to write the problem on the board. Remember, we're staying silent. We're thinking in our head of the solution and what strategy we used. And you're showing me with your hand signals how many strategies you've come up with, okay? Our math problem is going to be 6 times 20. We're thinking in our head of the solution. And remember, if you've come up with one solution, think of a different way you could solve it. It's a different strategy. You guys are doing some great thinking. I love it. Remember too, if you're kind of stuck, we can do one of these. Sideways one is really awkward. But yeah. Bless you. All right, it looks like several of us have a strategy or two. We're going to do our turn and talk now. So quietly, I would like for you to turn and talk to someone next to you and tell them what answer did you come up with and how did you figure that out? All right, and we're going to come back together. Good sharing. I heard lots of great, respectful math conversations. Thank you. All right, so who would like to be brave and share the answer that they came up with? Just the answer, not the strategy. Clara. 120. Did anybody else get 120? Excellent. Did anyone come up with a different answer than 120? Everybody came up with 120. Okay. All right. So now let's talk about what strategies some of you used to come up with 120. Everly. All right, hold on. And you got to talk really nice and loud for me. So you took away the 0 like that. So now you have 6 times 2, right? So 6 times 2 equals 12, okay? And then you just added the 0 back in? Okay, so then we just added the 0 back in to get 120. Okay, thank you for sharing. What is another strategy we've come up with? Yes. So you did 20 times 6, which that was great use of that commutative property, right? That we can flip these numbers and they still are going to come up with the same product, right? Excellent. So you did 20 times 6. And then what did you do? Okay. So you used skip counting. So tell me more about that. How did you know how many times? You said you did 20, 40, 60, 80, 100, 120. So what math were you doing when you did your skip counting? How would we show that? So you used repeated addition. You notice that multiplication is repeated addition. So you did 20 plus 20. How many times are we doing this? 6 times, because we knew that 20 is being multiplied by 6. So you have 6 groups of 20. All right, so we have 1, 2, 3, 4, 5, 6. And then you said that that all equals 120, correct? That's how you did it? Excellent. Another great strategy. What is a different way? Yes. Okay, say that one more time a little bit louder for me, love. You said you broke the 20 in half. So you saw that. So you used, fancy word, decomposition. Everybody say decomposition. Not only in science does it mean that we're breaking things down and becoming part of the earth, but in math, it means we're breaking it down into smaller pieces. So you decompose 20 into 10 and 10. What math do you use, though, to make 10 and 10 equal 20? You used addition. Excellent. Okay, so you said 6 times 20. I'm going to take my 20 and decompose it into 10 plus 10 because you know that 10 plus 10 equals 20. And you also know that 6 times 10 was an easier thing to do, right? 10s times things are kind of, they come quick to us, I think. Okay, so I'm sorry. From here, you did, tell me what you did. You did 6 times 10 equals 60. And then you knew that you'd have to do this twice then. You added another 60. And so how did you get this other 60? Okay, so, well, this number, this, help me get there. You said the 60 you got because you had to do this again. Is that what you're saying? Okay, so then you did 6 times 10 again. And then you said you added 60 plus 60. So walk me through it. What do we do? 0 plus 0 equals right there, right? Okay, now what? Excellent. So you knew 6 plus 6 equals 12. And then overall, that got 120. Did anybody else use that strategy? You used that one first? Excellent. Do we have another strategy? Yes. Okay. So you did 20 on top and 6 on the bottom. We call that our standard algorithm, right? So did you visualize it like this in your head? Okay, then what did you do? How did you get the 0 at the bottom? So you did 6 times 0 equals 0. Is that correct? Okay. And then 6 times 2 equals 12. And you also got 120. Another great strategy. Do we have any other strategies? Did anybody come up with something else? Everly. Okay, I love it. All right, so we're going to do 6 times 20. And you said take away the 0. Okay, so you're saying you had 6 groups of 2. Is that what you're saying? And then you said you used skip counting by 2s. So you did 2 plus 2 plus 2 plus 2 plus 2 plus 2. 1, 2, 3, 4, 5, 6. Excellent. And then you said 2 plus 2 plus 2 plus 2 plus 2 plus 2 equals 12. And then you took that 12 and then what did you do? So then you said, whoop, we're going to pop that baby back in there and you got 120. Excellent. Do we have any other strategies? You all came up with, let's see, you came up with 5 different strategies on how to solve one problem. Are they all correct? Yeah. Is one better than the other? No. If you had to do this math problem again, now that you've seen some of your peers' ideas of how to solve it, I want you to think which number strategy would you use next time, or would you want to try with a different problem next time? Show me with how many fingers. Hold up how many fingers. Excellent. There's a lot of diversity. There's a lot of different ideas. I love it. So next time you're doing a math problem, or maybe if you get a chance to do a number talk again, you'll think back to all these different strategies and try a different way. And your brain is going to grow and be huge and know so much of how to take numbers and move them around to figure out the problem. All right. That is it. Thank you, my friends.